Hi, everyone. Can you hear me? My name is Ariel Todoki, and I'm a computer science student here at UW-T. And today I will be presenting on privacy-preserving text classification. This work was done alongside the student and professors also listed on this slide. So first off, if you don't know, what is text classification? Text classification refers to the labeling of text according to its contents. This text can be anything from your text messages, emails, health records, tweets, and pretty much any text document. And a text classification model is a machine learning model that was trained to take as input your text and then output its most likely category. So there are many, many applications for text classification. I'm sure all of us know about the ones in our emails that can detect spam emails, non-spam emails. On a more serious note, there are models that can detect if an author of a text could be suicidal or depressed. There are also models that can detect hate speech within text, cyberbullying, and there's just so many applications that are super important and relevant and super beneficial for us today. So what is privacy preserving? Why do we need a privacy preserving way of doing this? Well, machine learning models need to actually read and see these texts in order to do the classification. And giving applications access to our private text, such as our emails and our text messages, can lead to privacy violations. So is there still a way that we can benefit from these text classification models without having to give up our privacy of our text? Yes, there is. One of these ways is secure multiparty computation. It is a mathematical technique from cryptography that allows parties to compute a function together without learning what each other's secret inputs are. And this works by doing computations all on shares. These shares are pretty much secret inputs. They're distributed between the parties, so no one knows what the secret is. All the computations are done on the shares. In the end, they add them together to find the final result. So how do we use this technique to do our text classification? Well, all the computations we need to do can be broken down into additions and multiplications. And there are already known protocols that can do secure additions and multiplications. So we use these protocols as our building blocks to create the more protocols that we need in order to do text classification. So for example, we can use addition and multiplication to create the XOR protocol or a dot product protocol. So let's look at an example. We have Bob, who has a text classification model, and his model can detect hate speech against women or immigrants. And we have Alice, who has a text, and in this case, it's a tweet. And Bob would like to classify Alice's text as hate speech or not. But Alice doesn't want Bob learning what words are in her text, and Bob doesn't want Alice learning what words are used in his model. So first, what they need to do is create a feature vector that says whether or not there's a word from Bob's model that is found in Alice's text. A 0 meaning it's not found in Alice's text, and a 1 means it is found in Alice's text. And we created a secure feature extraction protocol that can compute this, but again, it's all on shares, so none of them actually learn what words are found in Alice's text. So once they do this, they can do secure classification. And in this case, Bob's model, it's either a logistic regression model or an AdaBoost model. And both of these can be computed using 4 secure protocols, and these are XOR, dot product, bit decomposition, and comparison. So Alice and Bob work together, they compute all of this, and in the end, they get the shares of the resulting classification. Alice will send her shares to Bob, where Bob will finally learn what the classification is. For our results, we have for the AdaBoost model with 500 features, we have our highest accuracy at 74.4% in detecting hate speech. And it took 28.3 seconds to classify 1 tweet. For logistic regression with 50 features, we have less time. It took 5.3 seconds, although the accuracy was slightly less for that model. And if you're thinking 28 seconds is pretty long to classify 1 tweet, there is going to be a trade-off between privacy and also computation time. And the only other existing method right now uses homomorphic encryption, which took 19 minutes to classify 1 tweet. So to summarize, we trained models to detect hate speech against women and immigrants. We created secure protocols to do feature extraction, text classification, and our results show that it is possible to still benefit from text classification models without giving up our privacy. Okay, thank you.